I'm pleased to introduce Kent Chamberlain. He's a professor emeritus in the Department of Electrical and Computer Engineering at the University of New Hampshire. Dr. Chamberlain has been at UNH since 1985 and served as immediate past term chair of the department from 2014 to 2020. He received bachelor's and master's degrees in electrical engineering from Ohio University and earned a PhD in computational electromagnetics at Ohio University as well. His PhD dissertation won an international award from the Radiotechnical Commission for Aeronautics. He has an extensive list of publications in his research areas, most recently in electromagnetic fields and human physiology. Dr. Chamberlain has received external funding from over 25 research sponsors, including the National Science Foundation. Along with several other editorial and reviewing positions, he served as an associate editor and is currently a reviewer for the IEEE Transactions on Antennas and Propagation, which is the most prestigious journal in that field. Dr. Chamberlain's distinguished career has had an international reach as well. He was a visiting professor at the SRM University in Chennai, India in 2010, and he received 2 Fulbright Awards, one of which was served as Fulbright Distinguished Chair at the University of Aveiro, Portugal. Dr. Chamberlain, we really appreciate you taking the time out of your busy schedule to speak with the Water District trustees today. Please all join me in welcoming Dr. Kent Chamberlain to the meeting today.
It's my pleasure to be here. Thank you so much for inviting me. And by the way, let's keep this informal because I'm here pretty much informally. This is not a formal assignment. I think that a good starting point would be for me to talk about a conflict of interest or a lack of conflict of interest. Because as you can see, and as you've heard from what people have said, this is emotionally charged. And there are a lot of people who feel one way and a lot of people who feel the other way. And what I'm here to do is to provide an unbiased view, and at least I hope it's unbiased. And so I feel like it would be important to take a few minutes to say a little bit more about me and any conflict that I might have about the presentation I'm about to give. So as you just heard, I was a professor and chair of the Department of Electrical and Computer Engineering, which if anything would give me a bias towards technology, and it's true. Spent my whole life, my whole career in technology, and I feel like appropriate use of technology is in the best interest of making people's lives better. Also, I served on this New Hampshire State Commission. It was charged with looking at the impact of wireless communication and 5G on human health and the environment. And it's important to point out that I did that for free. And I would go to drive to Concord and I would do that out of my own pocket. And not that to say that I'm a good guy, but just to say that I did it without expectation of getting a reward for my participation, just like I'm not expecting any rewards for my being here with you today. I also want to let you know that I've done a lot of research that involves communication. Some of you, any first responders, fire people, might be familiar with Project 54 out of the University of New Hampshire. And Project 54 was about establishing better communications for emergency responders, police, etc. So I'm really familiar with this idea of making sure that you have communications where you need it during emergencies and regular times. So the final thing to say is I'm here as a fellow citizen. This is informal, and I don't expect anything out of it, except I hope that I provide you with the information you need to make the decision that's in the best interest of the people of York. So how I've structured my presentation today is to answer some questions that I know some of you have, questions that were forwarded to me beforehand, and just questions that I know that people have. So in order to do that, I'd like to share my screen. And again, with the idea of being less than informal. It's not a formal lecture. If I'm going over something and I'm starting to move on to the next subject and I haven't answered your questions, please unmute your microphone and simply ask them. I don't want to move forward unless you have an understanding and a feel for what I'm trying to present. Why are we concerned about the placement of cell towers? And here is the answers. There's a large and growing body of evidence demonstrating that exposure to cell phone type radiation, I'll explain this in a moment, is harmful to humans and the environment. So this is something that we haven't heard about, haven't been that concerned about, except for, well, reasonably recently. And I'll be showing you the data that leads me to that conclusion in just a moment. Now, are there other types of cell radiation or types of radiation that are of concern but less concern? So some of the like the old TV stations, radio stations, FM stations, they do emit radiation, and that radiation has been shown to be harmful in high levels. But the newer radiation, the cell phone type radiation, the high-speed data, digital data transmission, is impulsive in nature and seems to have a far greater negative impact on human health and the environment. So that is what we're concerned about. So your next question may be, what is cell phone type radiation? And I started mentioning it just a moment ago, and that is high-speed digital. As you know, analog, or maybe you don't know this, analog is where something is sent over a continuous wave. When it's digital, it's sending ones and zeros, and oftentimes that information is sent in packets. So you're getting a burst of information, a burst of energy, and then it stops. And it turns out that seems to be what is most harmful to humans in the environment. Devices that transmit these things, this is a question I got, what all are the devices that we're worried about? It includes cell phones, obviously, cell towers, I'll talk about that in just a moment, Bluetooth, baby monitors, smart meters, cordless phones, Wi-Fi, IoT devices. IoT was mentioned by earlier, stands for Internet of Things. And as you put more digital things like light switches, light controllers, water meters and all that in your phone, you're adding more of these devices that communicate using the radiation that is of concern. So commonly asked questions too, what are the differences between the signals from different wireless devices? Now, you really don't need to know any of the details for this, but the one thing is that on the devices I showed on the last slide, they all emit the types of radiation that are of concern. So these devices that are fairly new, we didn't have digital baby monitors back when my kids were young, unfortunately. It could have been helpful, but now knowing what I know now, I wouldn't be using them. But just I want to give you some terms that you may want to know about, and that is frequency. Frequency are the channels. If you listen to FM radio, you listen to things in the 100 megahertz range, and the frequency, the number 98.6, represents the frequency of that channel. So now we're up at much higher frequencies, 600 megahertz to 5 gigahertz. A gigahertz is 1,000 megahertz. I know we're not talking about it today, but 5G, which is coming along, is going to extend that to a higher frequency range. And higher frequencies are of concerns, but I'm not going to be talking about 5G today. So different device types use different protocols. So what I'm talking about now is what are the differences between these different devices, between a cell phone, for example, and the wireless monitor and smart meters. So they generally are in the same frequency range, frequency band, I should say, but they're going to have different things, like they're going to use different codes to talk to each other, and they're going to irradiate at different powers. And I'll talk about that too, because obviously power is very important. So the different types of devices that you're probably familiar with, and the powers associated with them are listed right here. Bluetooth tends to be rather close communications, and it tends to be a lower power, like 100 milliwatts. And some of you may not know, but a milliwatt is 1/10 watt. Smart meters get up a little bit more powerful, and they're generally around a watt, which is fairly high in terms of power. I was kind of surprised when I found out how high a power they radiate. And your cell phone that you have in your pocket, or maybe don't have in your pocket, I encourage you to turn it in airplane mode if it is in your pocket, but that's around 600 milliwatts to 3 watts. So something you might be helpful to know, and that is, your cell phone adjusts its power depending upon how close you are to a cell tower. And so if you're far away, it goes to the full 3 watts, but if you're closer, it then can go down to as low as 600 milliwatts. And finally, the cell tower itself, that's fairly high power. It needs to be high power for reasons I don't want to go into, or I could go into if people have questions about it, but they can go up to 50 watts in more rural areas if they need to. So those are the different types of devices, ones that you may be familiar with, and the types of power that are associated with them. But
Dr. Chamberlain, can I
yes,
ask you a question?
Oh, and please, Kent.
On the cell phone, are those devices aggregated, or is the exposure or the power aggregated there? Say there's 4 cell phones in a home. Does that mean you can expect it to be 12 watts?
I'm really glad you raised that issue. Yeah, they do add together. So it is what's called superposition, so that the energy from all of these devices add together. 4 cell phones gives you 4 times the power. But one thing you should know is that because they transmit in a burst manner, it may be that at any given time, you only have the power from 1 cell phone, but it's now giving it to you more of the time. Or if they happen to be transmitting at the same time, you will get that 4 times the power from 1 cell phone.
Thank you.
And and actually the radiation from all of these devices, if you happen to be around them, will also add and have more of a negative effect than if you had only one of those devices. Just continuing on with these questions, and now it gets into antennas, because a number of people have asked me about that. Basically, what does an antenna do to a cell phone signal? And the answer is that they focus energy in a particular direction. And the flashlight is a great example, so I'll give it. So let's talk about having just a little light bulb right here. A single light bulb out in, I call it free space, out in the middle of nowhere, and it's going to radiate energy basically in all directions. So if I had to draw something indicating the pattern of this light bulb, it would look like a circle. Now, if you had something like a flashlight, and that's, again, I like to use this example because it's accurate, because light is electromagnetic energy. So let's say you have this flashlight. Boy, I'm a horrible artist. Students have volunteered to chip in and give me art lessons, but I never took them up on it. So if you have this flashlight, it's aiming from left to right, how would you draw its pattern? You would draw it like this, because it's concentrating the light energy in a particular direction, and it doesn't do anything to distort that light. It doesn't change it in any way. It simply causes the concentration of energy to go in a different direction. So knowing that is all you really need to know about antennas for what we're going to be talking about today. And does that make sense? You can nod.
Yes.
Okay.
So it's a 180, almost a 180 degree. It's not 360.
Well, actually, so here's my, I'll draw it up again. It's a little bit easier for my drawing tablet. So here is your phone, your flashlight. You're aiming it. And so in this case, it's all of the energy is going in this direction right here, or not all of it, most of it. Now, if you were standing behind this, so if you were back here, you'd probably see some illumination, but it wouldn't be very strong. But if you were in front of it, you might be blinded by it. So all an antenna does is it changes where the energy goes. It changes it in a particular direction. So as I know, it doesn't change the frequency or the information one single bit. You still have the same information, the same electromagnetic energy. And here's something that just an example of it. So here are 3 directional antennas. Antennas that might go on top of a water tower. And you use these directional antennas so that you can focus the energy in a particular direction, like what I'm showing right here. And that's what the color represent, is what the signals, the colors in this pattern right here represent the signal intensity in that particular direction. So you can see that if you were standing out here, you probably would not be receiving much energy at all from this antenna number 1. And oftentimes you put these directional antennas on top of a tower or a water tower so that you can have one antenna talk to people in this region right here, the other antenna talking to people down here, and finally the third antenna here. So it allows you to communicate with more people using a single tower. And that is part of what's being proposed. And I'll show you antennas from your proposed facility in just a moment. So this is horizontal. This is looking top down on the antenna. You know, the water tower might be here, for example. So you're looking top down on it. So you can see that the antennas in this case are meant to just concentrate the energy in different directions. And you can do the same thing to the side. So here's a side view of a directional antenna. This is referred to as the elevation pattern. And the reason you would want to concentrate the energy in this plane right here is because you don't need to communicate with people up here. What you're trying to do is to communicate with people in houses right here. So you want to communicate along the horizon because that's where your clients are, and you want to make sure they're getting an adequate signal. Somebody asked if you could have an antenna that would do something like this, that would have the energy go out and be weak and then get stronger as you went down. And the answer is no, you really can't do that. There is no such thing as a bending electromagnetic wave in free space. So just if I'm responding to a particular question in giving that answer right there. But here is what antennas do. They focus the energy both in the horizontal or the azimuthal plane, and they do it in the elevation angle. Are there any questions on antennas before I move on? It's just an important subject that some people have found to be confusing. All right, I'll move on then. And again, remember, I'm trying to get to a particular location to answer your fundamental questions. Here's just the examples of the pattern that came out that are proposed by AT&T. And so here is, remember, the azimuth plane. So this would be the top of the water tower. And here you're trying to concentrate your energy in people in this region out here. Whereas you might put a second antenna on the backside to communicate with people 180 degrees from that first location, from this location right here. So those are the antennas that are, this, by the way, these would be the properties of a single antenna. And so in terms of elevation, here would be the horizon right here. And you can see these right here, they're referred to as side lobes. You don't need to know anything about that for our current discussions, but just that the proposed antennas are going to be directional so they can address people on both sides of the water tower, and that this, from this plane right here, it wants to focus the energy towards the horizon. Here's an important one, and that is, how does the power from an antenna vary from distance? And this applies to any type of antenna. And this is, basically the bottom line is that distance is your friend. I mean, the specific answer is that you have this inverse square law that power drops off as 1 over r squared, where r is the distance to the radiator, any type of antenna. So to give you an example, let's look at a case of a person sitting with their cell phone on their desk. It's 1 meter away from them. And let's just call that, let's just say as a reference, that's 1 milliwatt per meter squared. It's not unrealistic. And if you move that antenna, the cell phone closer to you, then the radiation, and so now you've moved it closer to you, then the radiation has not doubled, but it's quadrupled because of the 1 over r squared law. And if you move it closer yet again, in other words, put it in your back pocket, then, oops, I don't know if that, yeah. Put it in your back pocket, you're going to get some huge amount of energy. And in this case, I'm calling it 24 kilowatts. You would need to do modeling to get an exact value, but this does give you a reasonable sense. You get a very strong signal, such a strong signal, in fact, that if you look in your user's manual, or if you look in the legal statements on your cell phone, it's there, you have to look for it. It says, don't put this device next to your body. It's not good for you. It'll harm you. But How many of us put our cell phones in our pockets, or worse yet, in our bras, and don't think a thing about it? So it's definitely not a good idea. What you want to do is keep as far as possible from the radiation source so that you'll have a lower exposure.
And we have a hand up.
Oh, okay.
The Gilardi family.
Yeah.
I'll just ask them to unmute.
Hi, this is Courtney Gilardi. I'm calling from the Pittsfield, Massachusetts community. My question to you, Dr. Chamberlain, is there any oversight of cell towers? So once this tower is up, will there be testing of the towers, and will that testing not just be to see if the tower is at FCC standards, but if that tower is at...
Actually, yeah, you gave me enough of a question that I can answer it. I'm getting a little bit ahead of myself with the answer. The answer is surprisingly no. I've done a lot of work for the Federal Aviation Administration, and you can't do anything with a facility without going out and measuring it to make sure that whatever you did to it didn't cause it to work incorrectly. But even when you put a cell tower in new for the first time, there's no requirement that you go perform certifications on that. So it could be that it's radiating very strongly and you're not going to know about it. But I'll talk a little bit more about that later on, okay? So I would like to move forward and answer kind of the key questions that I've been getting. And I know that this is what you want the answer to. What distance is safe to be from a cell tower? Should people of your heights feel completely confident that these antennas installed outside their bedroom windows and near their yards pose absolutely no health risk? As somebody else noted, and I put it in red because it came from our commission, and that is the New Hampshire report recommends that we put the cell towers, 500 meters or more from sites, from people. What long-term studies? So these are questions that I want to jump into right now and give you the answer. And it's going to take about 10 minutes to really come up with an answer. Then I have other things to provide supportive information. You'll have an answer fairly soon. Trust me. Now, what I'm going to give the next statements about involve one article. Now, I'm going to show other articles later, refereed journals, and I'll talk about what refereed journals are in just a moment. But here's the data as best we know it. And this article right here really tells what's going on. Basically, what this study does is it takes a look at a cell tower, not a cell tower. It takes a look at hundreds of cell towers. Oops, told you my artwork wasn't good. And then it looked at people living at homes in the vicinity of those cell towers. And it found out what the mortality was from a particular type of, or from cancer in general, and neoplasias in general. So if you live near a cell tower, what are the chances that you're going to die of neoplasias, of these cancers? And so they looked at not just one tower, but they looked at over 800 towers, and this is in Brazil. Now, one thing also to note is that these initial studies were done between 1996 and 2006, over a decade. So they took large amounts of data representing where people lived, what their proximity was to a cell tower, and how many of them were dying from cancers every year. So a pretty inclusive publication. And by the way, I'm going to make these slides available, and all that you have to do when you get those slides, they'll be in PDF format, is click on the link and it'll bring you to that article, and you can see if you draw the same conclusions from that article that I did, or that I'm doing right now. So let's move forward. I'm going to show you one plot that answers a lot of questions. And here's the plot. Let's go over it and what it means. So on the x-axis is your distance from the cell tower in meters. This blue line says what the rate of mortality from neoplasia is every year for the population in general, not just the people living near the cell tower. But if you're near a cell tower, what's showing up in red here is how your mortality changes as you get closer and closer to that cell tower. So the plot says a lot. So if you're close to the cell tower, you can see an appreciable increase in your mortality rate compared to the population in general. And a test that you can perform is, what if you get farther and farther away from the cell tower? Well, as you'd expect, you get roughly the same mortality as people who live way away from it, the population in general. So now to answer the question about where the 500 meters come from. Well, if you look at the curve, you'll see that there's a break in the curve around 500 meters. In other words, it was a pretty sharp increase, and now the slope is beginning to change as you approach 500 meters. Now, this isn't just a single study that I'm referencing right here. There's a lot of others. There have been a number of other studies that confirm what is being shown on this plot, but I thought it was just a really easy to digest plot that says, hey, as you get closer to these cell towers, your chances of getting a cancer are higher. Another important thing to say, very important thing, and that is we're only looking at cancer here. There are lots of other physical ailments, physical problems that occur as a result of exposure. We're looking at simply one of them right here. So let's put this in a little bit of perspective, this 500 meters right here, and look at what's going on in York. So here's a site that you've probably seen before. It's in fact, I got it from your proposal. And it shows the water tower and it shows the surrounding regions. And if you put in 300 meters, now why did I pick 300 meters instead of 500 meters? Well, 500 meters doesn't fit on this plot. So if you look at this, you'll see, that this is going to cover basically all of the neighborhood, all of the people who are shown, or whose houses are shown on this plot. And the Drews, I assume this is you also, that you're in this area. And certainly Wendy Roberts, you're in there also. So if you look within 100 meters, and then you go back to this plot, I mean, that shows pretty significant increase in risk from neoplasias. I mean, this isn't made up stuff. It's for real, and it just shows that your risk from just this one single disease is significantly increased. It might also be a time to talk about a question that I was asked. Oh, go ahead.
Dr. Chamberlain?
Yes.
So just going back to that chart, if you could flash that back up. So the increase from 1,000 meters to 100 meters is on this chart, it's like about 8%. Is that right?
Yeah, that sounds about right. Yeah. So this would be what, 44, so 14.
Yeah,
so
actually, to quantify that.
Oh, I'm sorry. So that would be actually 14 greater than 30. That's more than 8%. So
well, 34 to 44, about 10.
Okay. Yeah. So 10.
Is that right?
Yeah, 10 out of 32. So, but it's significant. And there are
okay.
lots
I just
of
want to make sure I was reading that correctly.
Okay. Yeah, you are. I want to respond to questions I've had about real estate values. I don't want to go into it in too much detail, but yes, this is something the New Hampshire Commission did look at, and we decided not to do too much about it in terms of requiring that you get RF readings in the house before you sold it. It just didn't want to go there. But one thing I'd like to point out is that yes, at some point, the proximity to cell towers is going to be a significant factor in housing prices. I'm showing you an article that was 10 years old. And why don't more people know about it? You'd think that with information like this, that people would be going, whoa, let's let other people know about it. But it turns out, as I've found out from serving on the commission, this information travels slowly for a couple of reasons. One is the news outlets. Where do they get a lot of their revenue from? They get it from cell phone companies. And so they probably would think twice about publishing something that says, hey, these cell phones that we're advertising are probably bad for you. So that's one reason that you probably haven't heard of this before. But over time, and I'm finding out, more and more people are becoming aware of this. And at some point, there will be that tipping point where people say, I don't want to buy a house near a cell tower. For the reasons that we're talking about here. As you get closer to the cell tower, your risks of certain very serious diseases increase. So before I move on, does that seem to address, or do you have questions about that? Because that is kind of the ta-da moment for this presentation. If you were on the fence about whether or not risk existed, this might push you over. So what are other people doing about it? I just want to also let you know that, and this is kind of back up my statement about more and more people are becoming aware of this. And that is that many communities have policies in place and ordinances, zoning to ensure that you don't put cell towers near schools for the reasons that I'm showing. It turns out that kids are a lot more susceptible to radiation than are adults. So where else have they done? This is just a partial showing of where else they've put in these setbacks. And I'm showing what the setbacks are. Palo Alto, California, you can read them yourself. Your neighbors up in Bar Harbor have done that. And notice their setbacks are about 1,500 feet. Why 1,500 feet? That's roughly 500 meters. So we had looked at some of these data in the New Hampshire Commission, and we came up with that setback for 500 meters. And I think that setback should not only be true for schools, but it should be true for homes too, for the reasons that you saw elucidated on that plot. Another question is, basically is what are the standards in other countries? But before I go to these standards, I'm going to flip back a few slides and go to this expression right here. This is from that initial study I showed you, the one from Brazil. And remember where they found the incidences of cancer, the strongest signal level they saw there. When they went out and made measurements, they had a meter very much like the meter that I have, and that meter showed 407.8 milliwatts per meter squared. So when you measure the signal level from these cell towers, those are the units you use, or something similar to it. And I can go over that if you have questions. So 407, I want you to think of that number as we go ahead and look at what the standards are for the United States and for other countries. So here we are, and if we look at, and so here, notice this is the flux density in what I said were milliwatts per meter squared, and 400 is roughly here. Can we call that 408? And so if you run that up, you'll see that in the United States, you are well below that threshold. And by that 408, you should want to be much lower than that. 408 was the highest level seen in that study, and that's where they know it causes cancers. And so you go to Japan, you're still in coverage, and finally you come down to Israel, you're kind of on the line. It says it's okay to be exposed to that level of radiation. But then look at China, Turkey, Bulgaria, Belgium, and they would be below that standard, and they would, if assuming that the level of radiation was actually being measured, they would be able to mitigate it or turn the site off. So where do we stand in the world? Our standards are very high. Very high in the sense that our thresholds are very high. So what goes on in other countries? The other countries do measure and publish RF levels. And as I was mentioning to the caller from Pittsfield, we don't require that we make measurements at cell towers even when after they've been installed. Now, there was a group that went around and made measurements on cell towers just randomly, and then a movement like that's going on right now, and they found several notable cases where the cell tower radiation far exceeded even the FCC standards. So I just want to mention that. And here's the question that many of you probably are asking at this point. Some of you already know the answer. Spoiler alert, I'll be telling you, but why are our regulatory agencies doing more? As I've mentioned, there are thousands of many documents, referee publications. Like I say, I'll talk about those in a moment. That say there is a problem with exposure to RF radiation. Other countries have much lower RFR, that stands for radio frequency radiation thresholds. FCC standards were set in the 1990s. In fact, the Telecommunications Act of 1996, Section 704 says you can't use health as a reason for turning down a cell tower placement. So, and also I should note that during our commission, the New Hampshire Commission, we approached the FCC from a number of different angles, asked them for speakers, sent them questions, and we never got adequate responses. They gave us BS responses. So the question is, what's going on with the FCC? And I'm going to answer it with a single slide. I could spend a lot longer on it. But catch this. It says, in fact, I'll read that in just a moment. The title itself of this report, and I should note that this report comes from Harvard University, so a prestigious university with ethics department, saying or identifying the FCC as being a captured agency. And the title alone, how the Federal Communications Commission is dominated by the industries it presumably regulates. If you want to, scary reading, get this report. It's online. It's linked right here. And, so if you want to link to it and read it, you can. And the one statement, which I think is worth reading, industry controls the FCC through a soup to nuts stranglehold that extends from its well-placed campaign spending in Congress through its control of FCC's congressional oversight committees to its persistent agency lobbying. In other words, the FCC has been taken over. This isn't conspiracy. It's not something I'm making up. This comes from Harvard University and explains a lot. And there's a lot of other information around that supports this. So very briefly, that's why the regulatory agencies aren't doing anything.
Could I ask a question?
Absolutely.
Going back to that graph that showed where the...
I just want to remind you that this is a presentation to the Board of Trustees. It's not open for public comment. Sorry.
I'm sorry. I thought he said we could ask questions. I misunderstood.
Oh, I'm sorry. I was talking to the trustees then. I really would like to open this up for public questions too, if we have time. So let me...
Well, we made that very clear. This is a presentation to the Board of Trustees only. It's not a public hearing. It's not,
okay.
Not open this
I
up.
I misunderstood.
So just one kind of an update on that, what happened, why the FCC's being a captured agency. It looks like there's progress being made in the courts because they are being sued right now. And this is in February of this year. The Environmental Health Trust is taking them to court, and it looks like they're making progress. This one comment from the judge is very encouraging. During oral arguments, one of the judges told the FCC, "I am inclined to rule against you." And I listened to some of that hearing, and the FCC was giving really lame answers to the questions that the FCC were, that the judge was asking, the same type of questions that we were asking. Like, why won't insurance companies insure cell phone radiation? But I'll mention more about that later. So things are moving forward, that at some point, and if this lawsuit is won, it could bring about great changes in the way cell towers are located. So moving right along, peer-reviewed publications. This is something that's been asked is, okay, you're referencing all these peer-reviewed publications. What is a peer-reviewed publication? The answer is that if I have an idea, a scientific idea, or I want to just express a theory that I have, I write a paper and I send that paper to a journal. And journals, whoever gets the journal will first of all look at it and say, well, does this belong in our journal? And if it does, they will send it out to experts in the field. And those are called reviewers. And so typically they're sent to 3 reviewers. I've seen it go to 5 reviewers though. And these are recognized experts. And to become a reviewer, you have to, and I'm a reviewer, you have to go through a little bit of a process to show that you're qualified to be a reviewer, such as your pedigree, your background, and papers that you've written. So it goes to the reviewers. Reviewers are generally not kind, or oftentimes are not kind. They're very thorough in making sure that what you've done is correct. And then they send it back with recommendations to the associate editor, and then it either gets published or it doesn't get published. So that is what a refereed journal is. So I'm going to be showing these, and then the next question that I get, and these are particular from proponents of 5G, and they say, oh, the only articles that say things that are bad about 5G and radiation are from fringe journals. I'm really not quite sure what a fringe journal is, but it suggests that there are low quality journals. But yes, there are low quality journals, but it's very easy to tell the quality of a journal, and I'll mention that in just a moment. One thing that I had to do as an associate editor for IEEE, the Institute for Electrical and Electronics Engineers, was to be aware of other journals. So I would use that information to evaluate the quality of publications. And also as a department chair, I had to know and be able to identify what a quality journal was. Because there are low quality journals where almost all papers are accepted. In fact, I saw one with an acceptance rate of 98%. So you can identify very quickly what those fringe journals are. And so what I did on these was to look at the publications and look at things like their impact factor, look at their citation index. There are a lot of things that you can do to find out if you're dealing with a quality journal. So the answer is that to them is to the people who say that there are only things bad about radiation in fringe journals. That's not the case. So one of the roles I played on the commission was to identify the quality of journals. And I'm about to show you some excerpts from journals that helped us make our decision. And every one of those is a quality journal. So let's start stepping through the data. It's a little bit boring, but I'll try to make it as palatable as possible. So here's an article. And so what I'm doing on these, and like I said, you're going to have access to these. I'm giving the article title, I'm giving a quote from the journal, and then how to get that journal. So if you want to go look it up, simply click on this within the PDF document and it'll bring up this article. So it says things like, in conclusion, the study shows that low intensity microwave radiation induces oxidative stress, inflammatory response, DNA damage. These are things you don't want to hear from your cell phone, that your cell phone does to you, but this is what's happening. In this article, this research article shows the details about how they came to that conclusion. Next one, and I don't want to dwell on these too long, but I can if any of the trustees have questions about it. This suggests that you have problems in your ear follicles from exposure to cell phone radiation. The same degree of cell phone radiation that you would have from holding your phone near your ear. And as we age, the last thing in the world we want to have happen is something else making our hearing less sensitive. Next article. These findings show that these electromagnetic fields have significant biological effects on skin fibroblasts. Your fibroblasts are what help provide collagen and help generate new skin. You don't want to have your electromagnetic radiation causing problems with that. Here is an important one. I mean, they're all important, but this one right here deals with psychological things that can happen as a result of exposure to cell phone radiation. Things like, when you can read them here, some of the important ones that I know people have reported deal with insomnia, headache, depression. Now, a lot of these, there are a lot of causes for these, but one thing I recommend to you is that if you or anybody else in your family suffers from insomnia, get in the habit, try this for a week of turning off all electronics. Put your phones in airplane mode, turn off your Wi-Fi, and see what happens. I've heard from a number of people that all of a sudden their insomnia goes away, they're sleeping better, and there are other problems that tend to go away, other physical problems. Just be aware of this. I could say more about it, but I want to move through the material. Male fertility, this is a big thing. Perhaps you've heard about it. It's in decline. The male sperm count is down, as is the motility. And that's happened roughly during the period that we've had cell phones. And it's a significant decrease. So cell phone exposure, and oh, by the way, and where do men carry their cell phones? Right close to the area that's going to generate the sperm. This one involves blood, and in particular the blood in the placenta, and it shows that there are changes, and they've done the studies that showing that there are very discernible changes due to radiation exposure. Here's one that if you're interested in the environment, there are a number of studies that look at what happens to the vegetation in the vicinity of cell towers. And it turns out that not good things happen. That first of all, you start getting degradation of the vegetative growth on the inside, the side facing the cell tower, and then that degradation spreads to the entire tree, and it happens to other types of vegetation. So even that should tell you that there are problems with cell phone radiation. And also insects. We all know and we've heard about how insecticides affect bees and other pollinators. It turns out that you get a double whammy if you at the same time expose them to cell phone radiation. So it impacts the environment, you know, the trees, flowers, and insects. So a commonly asked question I get after that, and like I said, I could go on for thousands of those articles. I didn't want to bore you with them, but I wanted to show you there's a big evidence, a body of evidence, showing that there are a lot of different types of problems, not a single type of problem, but many different types of problems from cell phone radiation. A commonly asked question number 5. And that is, did the published studies show harm with cell phone? Did all the published, that's got to get that word in there. And the answer is no. You know, some of them shows problems and some of them don't. And by the way, I should point out in the early studies of smoking and its effects, the early studies of asbestos and you name it, sugar, trans fats or whatever, not all of them showed problems. In fact, only like 5 out of 6 people who smoke get lung cancer. So that's a conflicting or contradictory evidence. For every person, every long-term smoker that dies of a ripe old age of something other than lung cancer, that's a bad data point. So usually early on, you start getting these contradictory information. And then as more and more information piles in, you start getting more and more certain of a particular claim, like the claim that cell phone radiation is not good for you. So here's an example, and this answers the question about who depends on who funds the research. This comes from a guy, Professor Harry Lai. He's at the University of Washington, looked at 126 cell phone radiation studies, and he found that only 28% of the industry-funded studies showed biological effects, whereas 66% from non-industry funded research found biological effects. So that's kind of says a lot. So yes, scientists can be bought. And that's one reason I didn't want to accept any money for giving this presentation. So this information, remember I said that as time goes forward with a claim like this, it either proves or disproves it. So if you look now, flash to 2020, in the updated figures, the neurological studies, 76 or 73% of the studies showed a problem or effects with radiation. You look at genetic effects, 65% of the studies showed that there was an effect. And with free radicals, it's up to 91% because that's one of the main concerns about exposure to the fields is it causes oxidative stress, which leads to these reactive ions. So that's what's happened. That answers the question, I hope, about whether or not they all show a problem. Well, no, they don't. So the conclusion, I'm now flashing back to the commission, just to give you briefly, I'm getting near the end, by the way. Our conclusion, cell phone radiation, including 5G, poses a significant threat to human health and the environment. The relative risk is not clear, and that's why we need more studies. And this relative risk, it's important for me to point this out, and perhaps now, and that is, if you know what the relative risk is of something, you can decide whether or not it's worth doing. Here's a great example, and that is, we lose about 35,000 people a year on the highway. They die in auto crashes, and a lot more of them are maimed. That's the risk. It's a known risk. But what are the benefits? Well, we get to drive around. So for most of us, we've made the choice that, hey, I want to drive my car and I understand what the risk is. The issue with cell phone radiation is we don't know what that risk is. So I, as a user, can't really decide whether or not it's worth it. So we need to do a lot more research. The other thing, and we did discuss this analogy in the commission, and that is when it comes to a car, you make the choice. Do you want to drive? Do you want to take that risk? And you can make a choice about what car you buy and how you drive it. With cell phone radiation, you're not given that choice. The radiation is there. You're exposed to it 24/7, and there ain't nothing you can do about it. And that's one reason that I'm passionate about this. That, coming from the live free or die state, we believe that you should have a choice as a citizen as to whether or not you're exposed to something potentially harmful. Didn't mean to get on the soapbox there, but I did. So we also decided that this is not a scientific issue, it's a political one. But you need to understand the science behind it, and that's what I've been talking about. And until those radiation guidelines and policies are changed, there's not much you can do as a municipality in terms of stopping the placement of a tower. Continuing on, our general recommendations. We're going to seek independent evaluation of FCC guidelines, and how we're going to do that is we're imploring our federal delegation, our federal senators and representatives, people from the House, to put pressure on the FCC. Although if the lawsuit is successful, the one I mentioned earlier, they may not have to do anything. But to get those rules changed to something more realistic, take action to alert the public. If people knew that cell phones were of concern, they would probably put them in airplane mode when they had them in their pocket. They would certainly pay more attention. And encourage the migration to wired networking. I grew up, when I started using the internet, it was on wires. It's a lot faster. You don't get the radiation, and we still have much of the infrastructure in place. And there is money available to put in wired networking if anybody's interested, but we're not going to get into that right now. We also want to perform radiation. We're advocating the performance of radiation measurements. We talked about this earlier. Just if you're going to have a cell tower, not only make the measurements on commissioning, but also periodically go around and make sure that nothing's changed. And then work with whomever, with groups, to protect trees, make this an environmental issue. Right now, we can't use health as a reason to block the expansion of cell towers, but it's possible that we can do things environmentally, because it has been shown that it has an impact on the environment. So that's it. I hope I haven't worn you out with that, but I'm now set up to answer any questions you might have.